Hi, welcome back to CSI, The Science Revealed. Up next we have a segment on how rigor mortis works. To know how rigor mortis works, first you have to know about muscle contraction.
An electrical signal called action potential travels down a nerve cell, causing it to release a chemical message called the neurotransmitter into a small gap called the synapse between the nerve cell and muscle cell. The action potential spreads along the muscle cell and enters the cell through the T-tubule.
The action potential opens the muscle's calcium store in the sarcoplasmic reticulum.
Calcium ions flow where the actin and myosin filaments are bind to troponin and tropomyosin molecules on the actin filaments.
While binding calcium ions, troponin changes shape and slides the tropomyosin out of the grooves of the actin, exposing the actin-myosin binding sites.
Myosin interacts with actin by forming cross bridges. The cross bridges extend with ADP and phosphate attached to the myosin.
As soon as the cross bridges form, the myosin heads bend, thereby creating force and sliding the actin filament past the myosin. This process is called power stroke. During the power stroke, myosin releases the ADP and the phosphate.
Once ADP and phosphate are released, a molecule of ATP binds to the myosin. When ATP binds, the myosin releases the actin molecule. Once this happens, the ATP molecule gets split into ADP and phosphate by the myosin. The energy from the ATP resets the myosin head to its original position.
After the action potential has stopped, calcium is no longer released, and pumps located on the sarcoplasmic reticulum remove calcium.
It returns to its normal shape and allows the tropomyosin to cover the actin-myosin binding sites on the actin filament again. Because no binding sites are available now, no cross bridges can form and the muscle relaxes. Mortis muscles need ADP in order to release from a contracted state. It is used to pump the calcium out of the cells so the fibers can unlatch from each other. ATP reserves are quickly exhausted from the muscle contraction and other cellular processes. This means that the actin and myosin fibers will remain linked until the muscles themselves start to decompose. This is useful for crime scene investigating because the state of the body can help give an estimate for how long the body has been dead for.